Okay, so in this video we are going to just give an introduction to kinematics. Okay, kinematics, introduction to kinematics. Now, what is kinematics? That's the first question that we are going to start asking ourselves. What is kinematics? Well, kinematics is the branch of mechanics. Kinematics is the branch of mechanics if you want, you can say branch of mechanical physics, branch of mechanics that is concerned with the motion of objects, that is concerned with the motion of objects without making reference to the force causing the motion, without making any reference to the force causing the motion. So this is very important. So kinematics is the branch of mechanics or mechanical physics that is concerned with the motion of objects without making any reference to the force causing the motion. All right, now let me start off on this topic, on this subject, with Newton's first law of motion. We need to understand that Newton's first law of motion. I want to emphasize something. Newton's first law of motion, it somehow connects with what has been put here. Newton's first law of motion states that an object will continue to be at rest. An object will continue to be at rest or continuous motion, unless an external force has been applied. Very important. Now, if we connect what we have here and what we have there, you're going to see that every motion is going to be caused by a particular force. Okay, every motion is going to be caused by a particular force. We're saying that kinematics is the branch of mechanics that is concerned with the motion of objects without making reference to the force causing the motion. So under kinematics, the idea is to study the motion. We don't normally consider the force which is causing the motion. So every motion that is going to be made will be as a result of a particular external force being applied. All right, now when you're talking about motion generally, under physics even, the kind of motion under kinematics can either be linear motion or projectile motion. So there is what we call linear motion, and there is also what we call projectile motion. So there is linear motion and there is also what they call projectile motion. These are the two mostly observed types of motion anytime we're involving kinematics in this picture. So Kinematics is the branch of mechanics that is concerned with motion of objects without making reference to the force that is causing the motion. This is in agreement with Newton's first law of motion, suggesting that an object will continue to be at rest or continuous motion unless an external force has been applied. So, having this foundation, let us now try and see some physical quantities that are involved in this kinematic topic. What physical quantities are involved anytime you're simply talking about kinematics is the first question that we are going to start asking ourselves. So the first one that I'm going to put on this subject will be displacement. That's the first one that I'm going to put in this subject, displacement. What is displacement? That's the first question that we are going to start asking ourselves. What is displacement? Well, displacement, by definition, displacement is the distance covered in a specific direction. Displacement. This is the distance covered. Distance covered in a specific direction. So this is the distance covered in a specific direction. That's how we can define displacement. Distance covered in a specific direction. And in case maybe you're having point A and point B, okay, maybe these are two towns, point A and B, and you're trying to go to B. The actual path that can be taken might maybe be shown like this. There is no idea of having a specific direction in this path that is being taken. But if a new path was to be created here, just from A to B, you're going to see that this path that is being created here is having a specific direction. This path, this distance that is being covered from A to B in a specific direction, with a specific direction, is what is going to be referred to as displacement. Displacement. So as usual, displacement is a vector quantity, and displacement is mostly represented by the letter S. Okay, displacement is mostly represented by the letter S. All right, so in this video we're just going to be dealing the theoretical part. The calculation part, the practical part will also be addressed. So this is a distance covered in a specific direction, just like that. All right, now number two, we can also talk about velocity. Velocity is the derivative of displacement. What I mean when I say that velocity is the derivative of displacement, I mean that this is the rate of change of displacement. This is the rate of change of displacement with time. Rate of change of displacement with time. So velocity is the rate of change of displacement with time. Now, mathematically speaking, this can be shown like this. It can be written as V with a bar. I'll explain very carefully. Will be equal to, and then mathematically speaking, you can write this as ds dt, but more commonly this is just going to be written as change in s over change in t. Okay, change in s over change in t. All right, change in s over change in t. And this velocity that we're talking about here is measured in meters per second. Those are the units. So this is the symbol for displacement S. Okay, so S is the symbol for displacement. The units, of course, are just going to be the meters, SI units. Velocity, the units for velocity, the SI units are the meters per second. Okay, and as usual, it's just represented by V bar. So this velocity here can also be called average velocity. Okay, velocity at times can be addressed as average velocity. It's the rate of change of displacement with time. All right, now velocity here can be branched out into many categories. For now, I'm only just going to give two categories or two types of velocity. Okay, the first one that I'm going to give you is something which they call instantaneous velocity. Okay, the first one which I'm going to give you here is something which they call instantaneous velocity. Okay, instantaneous velocity. So instantaneous velocity, this is just the velocity of an object at a specific point in time. Okay, this is just the velocity of an object at a specific instant or point in time. Okay, this is velocity of an object. This is just the velocity of an object at a specific point time, specific point in time. Okay, at a specific point in time. All right, so that's what can be referred to as instantaneous velocity. But in the case whereby you're trying to be more scientific, this is just the first definition that I've given. So this is the velocity of an object at a specific point in time. Or if you want, the second definition that we can give, the same way we have defined average velocity to be the rate of change of displacement with time, here we say that this is the limiting value. That's what we say. We say that this is the limiting value. This is the limiting value of the average velocity. This is the limiting value of the average velocity. And of course, average velocity is just ds dt. This is the limiting value of the average velocity as the time interval. As the time interval, which is changing t, approaches 0. Two definitions that you can give. If you want, you can say that this is the velocity of an object at a specific point in time. Or if you want, you can say that this is the limiting value of the average velocity. Remember, average velocity is just ds dt, or change in s over change in t, as the time interval change in t approaches 0. So how can we try to differentiate velocity, or this average velocity, with the instantaneous velocity? How can we try to differentiate them at some point? How can we do that? Well, imagine we are having an initial point here, which is O, and you're heading, maybe say, to this point here, which is D. Okay, which is D. Well, let us imagine the motion here is in the x-axis. Okay, let us imagine the motion here is in the x-axis. So because the motion here is in the x-axis, at this particular point, I can say this is going to be position 1, or displacement 1. Okay, and then my point D, where I'm trying to reach, I can call this as my displacement 2. Or if you want, I can say S naught and then S final. It's fine. Okay? So, when we're talking about average velocity only focuses on the initial and final positions. Average velocity only focuses on the initial and final positions. Alright? That's the whole reason why this formula for average velocity can be extended to ds dt. This can be further extended to S final, displacement final or position final, minus displacement initial or position initial. Okay, that can also be written in that way, and this is also going to be over time final minus time initial. Mathematically speaking, the word change can also be synonymous with difference, and anytime we're talking about the difference of any two values, subtraction is normally the thing that goes on there. So when you're talking about average velocity only focuses on the initial position and the final position. Okay, on the initial position and on the final position, provided that they are connected together in a linear way. It's not that thing whereby there is an aspect of general distance. No, they need to be connected in a linear way like this. Okay, so that is average velocity. It focuses on the initial and final positions. But when you're talking about instantaneous velocity, let us imagine there are other points here. Maybe say other point A, point B, and point C. Instantaneous velocity, just look at it. We're saying that this is the velocity of an object at a specific point in time. So the velocity that is just going to be strictly at time A is instantaneous velocity. The velocity that is going to be strictly at point B, instantaneous velocity. The velocity that is going to be strictly at point C, that is as well going to be termed as instantaneous velocity, because it is only focusing at a single point in time, at a single instant. Alright? But if you look at average velocity normally considers two positions, 2 points, the initial point and the final point. Alright? The initial point and the final point. But for instantaneous velocity, it locates or focuses only on those single points in time. Alright? But can there be a relationship between the average velocity and the instantaneous velocity? Can there be a relationship? Can there be a way in which we can connect them? Yes, there is a way in which we can connect them. If the velocity of an object is constant, one thing that you need to know is that the average velocity will always be equal to the instantaneous velocity. The average velocity and the instantaneous velocity are going to be equal only if the velocity of an object has been made to be constant. It's not changing. So the average velocity and the instantaneous velocity are going to be the same, are going to be equal. So this is the first branch that we can give regarding instantaneous velocity. Well, we can also talk about terminal velocity. Terminal velocity. What is terminal velocity? Now, terminal velocity is the highest speed. Better let me use the word velocity. This is the highest velocity. This is the highest velocity. Highest velocity This is the highest velocity of an object. As it falls. Look at the keyword. As it falls freely. So the keyword that we use here is freely. As it falls freely. Okay, as it falls freely. As it falls freely in a gas or liquid. As it falls freely in a gas or liquid. In a gas or liquid. If it is falling in a gas, or more just simply in air, as it is falling in air, an object will attain terminal velocity if its weight equals the atmospheric pressure or atmospheric resistance it is experiencing as it is falling. Okay, so take note. Terminal velocity for an object that is falling freely in air or the atmosphere will come about when its weight equals the air resistance force which it is experiencing as it is falling freely. All right, so much more light is going to be shed on this. Okay, so for now, this is the highest velocity of an object as it falls freely in a gas or liquid. Instantaneous velocity as well, don't forget this. Average velocity as well, yeah, don't forget that. Let us go on this one, acceleration now. Acceleration. Well, acceleration is easy. Acceleration, by definition, this is the rate of change. Rate of change of velocity. This is the rate of change of velocity with time. This is the rate of change of velocity with time. That is acceleration, the rate of change of velocity with time. Okay, with time. So this can just be termed as average acceleration. It is the rate of change of velocity with what? With time. This can be shown as this. A, the bar if you want, will be equal to, and then this is going to be dv dt. But this is normally written as change in v over change in t. Okay, yeah. But again, a question can be given to be like, can the acceleration be expressed in terms of displacement? Because we saw that the velocity was expressed in terms of displacement. So the question is that, can the acceleration as well be expressed in terms of displacement? Well, yes, it can. If we apply some concepts of the calculus here, this is just going to be written as d2s. It's the second derivative of the displacement, second differential expression for the displacement. So this can be written as d2s over dt squared. But just notice for now that in terms of the displacement, your acceleration can simply just be written as d2s over dt squared. It's the second differential expression, second derivative for the displacement. Okay, dt squared. Now, having established these facts, the common formula for acceleration is just going to be v minus u over t, okay, over t, or let me just say tf minus ti, okay, tf minus ti, okay. So v is normally the final velocity and u is the initial velocity, but I can try to just make them to look the same. Up here I'm just going to say v final, and then on this guy I'm just going to say v initial. But even u can be used to represent initial velocity, but I'm just trying to make them look more of the same. So t final minus t initial, that's going to be our formula for now for acceleration. But we can branch out from average acceleration to instantaneous acceleration. We can branch out as well to something which we call instantaneous acceleration. Instantaneous acceleration. Instantaneous acceleration. It's just the same way of going about it in terms of definition. The same way we did it when we were talking about instantaneous velocity, velocity of an object at a specific point in time. We're talking about instantaneous acceleration. Instantaneous acceleration is going to be the acceleration. Okay, so this is the acceleration. Okay, this is acceleration. Okay, this is the acceleration. The acceleration of an object. Acceleration of an object at a specific point in time. At a specific point in time. This is the first definition that you can give. 2, you can just say it in the same way we did it. You can just be like, this is the limiting value. This is the limiting value. Limiting value of the average acceleration. This is just the limiting value of the average acceleration. This is just the limiting value of the average acceleration, which is just dv dt as the time interval. As the time interval delta t, or change in t, approaches 0. Approaches 0. Yes, as the time t approaches 0. So this is the foundation that we can give for at least an introduction to kinematics. This is just the rate of change of velocity with time, acceleration. This is just like average acceleration in terms of velocity. It's change of velocity with time. In terms of displacement, it's going to be the second differential expression for the displacement. But average acceleration is just going to be given by final velocity minus initial velocity over final time minus initial time. But it's okay. A lot of people are well familiar with this one. V minus u over t, it's fine. We put here only a single t, only if the initial time is considered to be 0. That's the reason why normally we just put t, because the initial time is mostly considered to be 0. V is your final velocity and u is your initial velocity. So If a person chooses to express it in this way or write it in that way, there isn't that much of a big difference. But we normally use this one if the initial time is considered to be 0. This is instantaneous acceleration and all that. So this is an introduction to the kinematics that we can give. And one more thing. We're saying that this is the branch of mechanics that is concerned with the motion of objects. Motion means movement, right? Anything that is going to be in motion is going to possess kinetic energy. Anything that is going to be in motion, anything that is going to be moving is going to possess kinetic energy. Know that any body, any object that is in motion possesses kinetic energy. And lastly, we're seeing that the acceleration is the change of velocity with time. But the question is that, what if the velocity is not changing? What if the velocity is constant? Well, if the velocity is constant, there is no acceleration that is being made. So the acceleration quantity will come in if velocity is changing. If the velocity is not changing, there is no acceleration that is being produced at that moment. Okay, there is no acceleration that is being produced at that moment. So that's also another important point that you and I should just know. So thank you very much for having time to look up into this introduction to kinematics.